after executing of the following instruction. Alright, so it says that the instruction are executed sequentially. Okay, so executed sequentially. Okay, note you may ask. Okay, so this is a 12. Total mark is 12 mark. You can see here you have how many boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so usually for this kind of question, one box equal to 1 marks. Okay, so make sure that you do it correctly because this is a related the answer from top to the bottom is related to one to another. So make sure that you not do any wrong at the top of this question here. If not, the whole of this answer will be wrong. Okay, so let's look at the first instruction. Load I R20 R16. Sorry, load I R2016. Okay, so in this case here, this is a what type of number system? 16 here, is it a hexa or binary or octal or decimal number? Okay, so this is a decimal number. So what you're going to do is you need to convert this 16 decimal number to hexa number. Okay, by pressing your calculator, then you will get what value here? 10. Is it correct? This is equal to 10. So R20 now will have 10. Okay, so you put nombor 16 to your R20, which is this number 16. If convert to hexadecimal, you will get 10. Okay, so make sure that the value here is 10. Okay, no need, don't put 16. If you put 16, then the answer will be wrong lah, because the question asks you to put all the answer here in hexadecimal numbers. Okay, next, load IR21 with this number 0B10101010. Okay, so for this one here, you need to convert this binary number to hexadecimal. So how to do that? Okay, by using a 4-bit boundary group. Okay, so you will get what value here? You get R21 A. Okay, A. You will get A. Okay, hopefully all of you get the same answers. Okay, next, SEC. So what the SEC do? Okay, by referring to the what we call here your instruction set summary. Okay, SEC stand for set your carry flag. So what happened to your carry flag? So your carry flag after you execute this instruction will have what value? Is it 1 or 0? Okay, so by looking at your what we call here your instruction set summary, says that 1 put to your C. So you know that the C equal to 1. Okay, next we have a ADC R20 R21. What the ADC do? Okay, so ADC stand for add with a carry. Okay, so you need to add R20 plus R21. Okay, which is this is your R20. What is the value of R20? 10. Plus with R21, which is AA. And then C plus with your carry. What is your carry flex? 1. So next, what are you going to do? Okay, you add this number here, then you will get what value that you get? Berapa dapat? Anyone? AA plus 10 plus 1, you will get PB. Okay, so this BB will be stored at what register? Is it R20, R21? Which one? Okay, so here, you see here, this is the result, will be stored at R20. So your R20 will have BB. What about your R21? What is the value of your R21? The R21, the value remains, which is AA. Masih lagi AA. Okay, the value here is remains. And what about your C flag? Is it your C flag now remains 1 or 0? Okay, so C flag is 0. Why? Because after you add this number here, okay, you add this number by using a binary lah. Okay, convert this hexa to binary and then you do the addition, and then there is no carry flag from bit 7 to bit 8. So the C flag equal to 0. Okay, next. ASR R20. What does ASR do? What is ASR? Arithmetic shift right. Okay, so how the ASR works? Macam mana ASR ni? How the ASR works? Tadi kat sini. Okay. ASR. So it says, okay, if you refer to instruction set summary, okay, ASR, where is my ASR? Okay, it says that RDN, okay, and then it says something like this, RDN equal to RDN plus 1, okay, which is your n starting from 0 to bit 6. Okay, so by looking at this operation here, you know that, okay, you have a bit 7 until bit 0, and you know that this bit 7, you copy back the numbers. Okay, what about the rest? Okay, the rest, okay, you shift to the right by 1 bits. Okay, so this is what the ASR do. Okay, so now what is your R20? R20BB. Okay, so BB convert to binary number actually is 1, 0, 1, 1, 1, 0, 1, 1. Betul tak? If you convert to binary number. Okay, and then what you're going to do? Okay, do the SR, arithmetic shift right, copy bit 7, and then after that, you shift all of the bit to the right by 1 bit. Okay, so this one become 1, 0, 1, 1, 1, 0, and 1. And then get the hexa numbers. So what is the hexa number? 8 plus 4, 12 plus 1, 13, 13 convert to hexa equal to A, B, C, D. Right? So you get DD. Okay, next. MOVW. Okay, R23, R22, R21, R20. Okay, so what this instruction do? Okay, this instruction says that you're going to move one word or one pair of the register to another pair of your register, which is you're going to copy from R21, R20 and put it to your R23 and R22. Okay, so what happened here is R20 masih lagi, what is the current value of R20? Is it BB or donkey? Okay, so DD. What about R21? Masih lagi AA. R22? DD, and this one here is AA. Okay, so R21, sorry, R20 is DD because D is your current value. Okay, don't put BB bola to your R20. Okay, which is wrong lah, because now your current value of R20 already changed after you execute this instruction here. A is R20. Okay, all of you get this answer here? Semua dapat macam ni tak? Okay, next we go to SBR. Okay, so SBR R23 OX05. So what is a SBR? Okay, kalau kamu tengok kat sini SBR. Okay, so this is the SBR. Okay, it says that you're going to set bits in a register. Okay, and then this is the formula. Okay, RD equal to RD. What formula is this? V with K. Okay, you're going to do logical or with your K value. Okay, so I padam to this one. Okay, so R23. What is your R23? Berapa kita punya R23? Our current R23 is AA. So 10, 10, 10, 10. This is your R23. And then you're going to do a logical OR with 05. Okay, so 05 is 0, 0, 0, 0. And then 0, 1, 0, 1. Okay, so you do the logical OR. So what you get? 1, 1, 1, 1, 1, 0, 1, 0. So you get AF. Is it correct, AF? All of you get AF? Not AFZAN, yeah? That is my name. Okay, it's only AF. Okay, so the answer is AF. Okay, next. ANDI R22 with 150. So you're going to do the logical AND immediate with value 150. So how to cheat, sorry. This 150 is in decimal. Okay, every time you see the ANDI, ADD, ADC, okay, you're going to change the number to binary. Okay, so macam mana nak buat ni? 150. Okay, let's lah, you doesn't have any, what we call here, calculator. Okay, so what are you going to do? How to change 150 to binary number? Is it? Can somebody tell me how to change from this decimal number to binary? Let's say you doesn't have any calculator with you. How? Okay, you can use division by 2 methods. Okay, that is the longer method lah. Or you can simply what we call here, you can simply write down the weightage of each of the bits. Okay, dapatkan dia punya weightage. Okay, so starting with 2 power of 0 is 1, 2 power of 1 is 2, 4, 8, 16, 32, 64, and 1 to 8. Okay, so you already have 8 bits kat situ. Okay, starting from 1, 2, 4, 8, 16, 32, 64, and 1 to 8. Okay, now you're going to, okay, so the decimal number is 150. So if 150, so 1 to 8 should be 1 lah. 128, you need to put 1 kat situ. Okay, so 150 minus with 128, so the remaining is 22. Okay, how to make the 22 by using this weightage? Okay, so you see here, 64 cannot, 32 also exceeded 22. What about 16? Okay, so you put a 16. Okay, so 16 minus with 32, you need another 6. Okay, 8 cannot 4 plus 2, and this one is 0. So this is your binary numbers. Okay, so binary numbers. So R22, what is your R22? R22 is DD. Mana kita punya DD tadi? Okay, never mind. So I just write down here. 1. What is D? D is 13 kan? Okay, 1011. 1011. Okay, and then you do the logical AND with this number. So you will get 1001 0 0 1 0. So the final answer will be 90. Okay, sorry. D is 1101. Okay, salah eh. Okay. One one zero one 1101. Okay, so this is your DD. Okay, so 1001 and 10100. So the answer will be 94. Okay, next, swap. Okay, what the swap do? Okay, the swap here means that you're going to swap the position between low neighbor and high neighbor. Okay, so 4 will go to location position 9, 9 will go to 4. The final answer is 49. Okay, semua dapat tak jawapan ni? Okay, if yes, then we do another exercise. Okay, so this one here. Okay, I give you another 10 to 15 minutes to finish it, and after that we do discussion. Okay, please let me know if the answer is wrong, because I don't have any schema with me. So if my answer is wrong, just let me know. Okay, given that the register value, okay, you have a 4 register R20, R21, and R23, which F3, FD, 1, 3, and F1. Okay, you're going to find out what are the value of this register here after you execute all of these following instruction. Okay, so it says that the instructions are executed sequentially. Okay, so let's look at the first instruction here, LSL R20. So what the LSL do? LSL, what is a LSL? LSL stand for logical shift left. Mana dia? Logical shift left. What is my logical LSL? LSL. Okay, so this LSL signs that, okay, so it's this bit 0 and bit 7. It says that, okay, 0 will go to your bit 0, while 7 will go to your C flags. Okay, so this is the LSL. So LSL R20, what is R20? R20 is F3. Okay, so F3 is 1, 1, 1, 1. And then 0, 0, 1, 1. So this is your F3. Okay, and then you're going to do the LSL. So what happens is, okay, 0 will go to your bit 0. So it becomes 0, and then the rest of the bit will shifted to the left by 1 bit. Okay, so 1, 1, 0, 0, 1, 1, 1. What about this one here? Will go to your C flags. Okay, so the answer here will be 8 plus 4 plus with 1, so this is a E. And then what about this one here? E6. Okay, semua dapat E6 tak? Okay, make sure that the answer here in hexadecimal. Okay, next, the second instruction, A and DI are 21 with 55. So what is R21? R21 is FD. So FD is 1111. What is D? D is 13. So 13 equal to 1101. So this is FD. And then you're going to do a logical AND with 55. So 55 actually is 0101, 0101. Do logical AND, so we'll get, okay, so the answer will be 55. Okay, semua dapat 55 for the second instruction. Okay, great. Next, we're going to the NEG R20. Okay, NEG R20. So what is this R20 do? NEG. What is a NEG? NEG stand for second complement. Okay, you're going to do a 2 complement to the value inside of your register R20. So R20, what is the register R20? R20, current value of R20 is E6. Okay, yang ni ya. So we take this one here. Current value is E6. Then you're going to do a second complement. So what you're going to do? Okay, from right to the left, find the first number 1. Okay, so this is your first number 1. So you copy back the value. What about the rest? The rest, you just invert all of these bits here. Okay, so 0, 1, 1, 0, 0, 0. And you will get, answer is 1. 8 tambah 2 is 10, which is 1A. Betul tak? 1A. Okay, if let's say like if you don't know how the NEG works, okay, you can see the what we call the operation here. Okay, it telling you that mana dia saya punya NEG, where is my NEG? NEG. Okay, dia bagi tahu kat situ RD. Okay, by looking at the operation here, RD sama dengan 00 minus with RD. Right, so what you're going to do is, you just press the calculator. Okay, make sure that your calculator in hexadecimal. 00 tolak with the value of your RD, which is 00 minus with E6, you will get FFFFF1A. So you just take the 1A, put to your result. Okay, next we go to the CBR. The next instruction is CBR R2150. So R21, what is a R21? R21, the current value of R21 is 55. Okay, and then you're going to do the CBR. Okay, so what is the CBR? Okay, mana kita punya CBR? Tak nampak ya? Okay, this is your CBR. Okay, you're going to clear bits in a register. Okay, so this is the operation. Okay, you look in this is your operation. RD equal to RD do logical AND FF minus with K. Okay, so what you're going to do? Okay, so this is your K. Okay, first, you need to FF minus with K. Okay, tolak dulu. FF tolak dengan 50. So FF tolak 50, you get berapa ya? I put here lah. 1111. 1111. Because I don't have any calculator here. So I just put 111111 minus with 50. Okay, so what is 50? 0101 0000. Okay, then I get 1111 0101. Okay, and then I need to end with my RD. My RD is 55, so this is my RD. So I end this number here, 1010 with 1111. Okay, and then do the logical end. So 1 with 1, you get 1, 0, 1 is 0, 1, 1 is 1, 0, 0, 0, 0, and 0. So the final answer will be 0, 5. Okay, all of you get 0, 5 kat sini. Semua dapat 05 tak? Okay, great. Now we going to the multiplication punya instruction. Okay, MULS, MUL, and MULSU. Okay, so the first one here, MULS. What the MULS do? Means that you're going to multiply between two sign number. Okay, you have two signs number. Okay, so in this case here, R20 and R21. Okay, what is your R20? The current value of R20 is 1A. Okay, multiply with R21. What is your R21? 05. Okay, first, what you're going to do is you need to check the bits. Okay, for R20 and R21. Is it a sign? Is it positive number or negative number? Because this is involve the signs S kat situ. So you need to check lah whether this is a positive number or negative number. If the bit 7 here indicates that it is a negative number, then you need to find out what is the magnitude of that number. Okay, if the bit 7 is 0, then you just simply take this number and multiply with that positive number. Okay, since 1A, okay, so 1A, if you're looking at here, this is what we call here 0. So this is a positive number. So positive number, you just take the 1A. And then next, what about 05? 05 also kat sini pun you tengok, it is another positive number. So you just take this magnitude. So 1A multiply with 05, you get what value? Siapa ada calculator? 1A darab 05. $82 ya. Okay. I just trust you. So 82. So you get 0082. All of you get this one? Semua dapat macam ni? Okay, so 82 will be stored to R0, while R1 you just put 00 in front, dekat depan. Okay, next. MUL R22 R23. So R22 is 13. Multiply with F1. Okay, because this is an unsigned number, so you can directly multiply 13 multiply with F1. What answer you get? Berapa dapat? 13 darab dengan F1. Anyone? 11E3. Okay, 11E3. Okay, hopefully all of you got the same answers ya. Semua dapat jawapan yang sama ya. Okay, the last one. Okay, MULSU. Okay. So R23 is your signed number, while R22 is your unsigned number. Okay, so by looking at this, this is unsigned, this is a sign. Okay, if you see here, R23, this is F. Okay, bila F, kalau kamu tukar hexadecimal to binary F, and 0001, this is a F1. Okay, you see here, bit 7, it is a negative number. So you know that R23 is a negative number. So you need to find out what is the magnitude of this R23. Okay, so sekarang ni kita tahu this is a negative number. So what you going to do after you find out this is a negative number? Okay, nak buat apa? Okay, please get the second complement. Okay, dapatkan dia punya second complement from right to the left. Find the first number 1. So this is the first number 1. So you copy back. What about the rest? You just inverted. Okay, 1, 1, 1, 0, 0, 0, 0. Okay, so this is become berapa kat sini? 0F. 0F which is convert to hex binary number, you will get 1, negative 15. Negative 15. Okay, so this negative 15, 13 convert to decimal berapa dapat ya? 13 convert to decimal. Can somebody help me? 13 convert to decimal. Okay, 19. So 19 multiply with negative 15, you will get negative berapa di sini? Cargas. Okay, negative 285. Okay, negative 285 convert to hexadecimal. What value you get? You will get F all the way, and then okay, E3 FF E3. Okay, so just take this number here. Okay, 2-bit number. Okay, so this is belong to R0 and this is R1. So the answer will be FF E3. Okay, semua dapat tak jawapan macam ni? Okay, all of you get the same result, correct? So I think we'll stop here. And then next week, we continue with new module number 7. Okay, any question for the module 6? Ada soalan tak untuk module 6? Okay, if no question, you may dismiss. Thank you, class. See you next week. Okay, make sure you sign the attendance.